Okay, so just like the degrees, we knew the radians started at 0. You've got to remember there are 2 pi radians in that whole circle. If you forget, remember that activity we did yesterday with the pipe cleaners, and there were a little more than 6 pipe cleaner lengths around? That's your 2 pi. Okay, cut that in half at the 180 degree mark, and you have pi. Cut it in half again at the 90 degree mark, you have pi over 2. From there, let's go to our 45 degree marks. Now, I know that from 0 to 180 degrees, that was pi. And if I'm looking at my 45 degree marks, I have 1 slice, 2, 3, 4 45 degree slices of the circle. So if the whole top half is pi, what's a fourth of that? What's pi divided by 4? Pi over 4. Okay, so the 45 degree mark is pi over 4. Okay, so I said from 0 to 180, the top half of my circle, that's pi. We've already decided that much. And I'm saying, okay, of that top half of the circle, if we're looking at just 45 degrees, we've got a 45 degree angle here, and then here, and then here, and here. So that's 4 pieces. That's where I get pi over 4, because my pi is being divided into 4 pieces. So 45 degrees would be pi over 4. Now, if 45 degrees is 1 pi over 4, what's 90 degrees? 2 pi over 4. What's 2 pi over 4 reduced to? Pi over 2. So 2 pi over 4, which is pi over 2, and we already have that one there. What's 135 degrees? 3 pi over 4. What's 180 degrees? 4 pi over 4, which is just pi. What's 225 degrees? 5 pi over 4. What's 270 degrees? 6 pi over 4. Now 6 over 4 reduces to 3/2. What's 315 degrees? 7 pi over 4. And what would my 0 degrees or my 360 degrees be?
8 pi over 4.
8 pi over 4, which is just 2 pi. Okay, are y'all with me so far?
That's probably going to get me more.
Okay, where's the 7 pi? Okay, where's the 6 pi?
So here's what I did. I started from 0 to 45. That was 1 pi over 4. And then 2 pi over 4. 3 pi over 4. 4 pi over 4. 5 pi over 4. 6 pi over 4. 7 pi over 4. And then 8 pi over 4.
So we're doing the pi, or whatever, trying to figure it out. We're just going about 45 degrees.
Yes, I was just looking at 45 degrees. I was trying to get all of my 45 degree angles. All right, let's talk about the 30 degrees. All right, for 30 degrees, if I look at the top half of my circle, from 0 to 180 degrees, that was pi radians. And I have one 30-degree section, and then 2, 3, 4, 5, 6. So from 0 to 30, that was 1. From 30 to 60, that was 2. From 60 to 90, that was 3. From 90 to 120, that was 4. From 120 to 150 was 5. And from 150 to 180, that was 6. So there's 6 30-degree sections. You can look at it this way. If there's 180 degrees in that top half of the circle, what's 180 divided by 30? What's 18 divided by 3? 6. There are 6 sections there. So if the whole top half is pi, how big is the 30-degree section? Pi over 6. Okay, so I'm going to go to my 30-degree mark. Let me erase this other stuff. I'm going to say 30 degrees is pi over 6. I'm counting by 30 here. So 30 degrees is 1 pi over 6. If I go up 30, I'm at 60. How big is that? 2 pi over 6, which reduces to what? Pi over 3. Alright, so I had 1 pi over 6, 2 pi over 6 reduced. If I add on 30 degrees again, I'm at 90. What's that? 3 pi over 6, which is pi over 2. What about 120 degrees? 4 pi over 6, which reduces to what? 2 pi over 3. All right, what about 150? 5 pi over 6. And 180? 6 pi over 6, which is just pi. What about 210? 7 pi over 6. 240? 8 pi over 6 reduces to what? 4 pi over 3. All right, so that was 8 pi over 6. What about 270? 9 pi over 6, which is 3 pi over 2. What about 300? 10 pi over 6, which is 5 pi over 3. And what about 330? 11 pi over 6. What about 360? 12 pi over 6, which is 2 pi. Okay, why is this called the unit circle? The radius is 1. We're operating on a radius of 1 unit. So if the radius is 1, and I'm talking about the coordinates, and I'm going from the origin out to 0 degrees, what are the coordinates there? 1, 0, because I basically moved over 1 and up 0. What are the coordinates at 180 degrees? Negative 1, 0, because I'm moving left 1, up 0. What are the coordinates at 90 degrees? 0, 1. What are the coordinates at 270 degrees? 0, negative 1. Okay, so start with the easy coordinates going around your x and your y axis. Then go on to the 45-degree angle. Do you guys remember the coordinates for your 45 degrees? I'll give you a hint.
Yeah,
The x and the y were the same. You're close.
No.
Square root.
Square root 2 over 2.
Square root 2 over 2. 45 degrees was square root 2 over 2. Square root 2 over 2. Now, 45 degrees, memorize that. It's easy because they're all 2's.
45 is half, and you just gotta think half of 2 is 45 or something like that. I don't know. I just gotta figure a way to remember that.
Figure out a way to remember it. 45 degrees, square root 2 over 2, square root 2 over 2. Well, that means we can get the coordinates for all of those 45-degree angles. The numbers are going to stay the same, but the signs will change. So when I look at 135 degrees,
Negative square root 2.
Negative square root over 2.
negative square root 2 over 2,
Square root over 2.
and square root 2 over 2. Why was the x negative there?
Because in the negative side, like you got.
It's on the negative half. It's in the second quadrant, and x is negative there. What about 225 degrees?
Is that
Negative
2 over 2 over
Whatever, yeah.
Negative square root 2 over 2, negative square root 2 over 2. They're both negative because in that third quadrant, x is negative, y is negative. What about 315 degrees?
Square root 2 over 2.
Square root over 2 over 2, and then negative square root of 2 over 2.
Square root 2 over 2, negative square root 2 over 2. The fourth quadrant, x is positive. It's on the,
Positive half.
the positive half, the right side of your graph. But your y is negative.
I bet you won't look like that for the rest of the class.
I would hope not.
Like what?
Okay, let's get your 30-degree angles. Now, everything else is based on 30 degrees. Your 30 and your 60 degrees.
Square root of 3 over 2.
30 degrees is square root 3 over 2, comma 1/2. Now, there was a way to remember this. Let me pick another color. If you are starting at the origin and you are trying to get to that 30-degree spot, I'm going to move horizontally first and vertically second, just like X, Y. So I move horizontally and then vertically. Which distance was longer, horizontal or vertical? Horizontal. I moved a long way and then I moved a short way. Square root 3 over 2 is bigger than 1/2. So if you move horizontally the long way, square root 3 over 2 is x. Vertically the short way, 1/2 was your y. Long versus short. Think about 60 degrees. If I'm trying to get to 60 degrees, I'm going to go over and then up.
It's the opposite.
It's the opposite because I'm moving short and then long. So for 60 degrees, it's going to be 1/2 and then square root 3 over 2. I moved short and then long. I moved a short horizontal distance and a long vertical distance. Everything else you're just sort of reflecting. So look at 120 degrees. 120 degrees is going to match what other angle?
60.
60.
Except this will be a negative 1/2.
Except it's going to be a negative 1/2. So 120 degrees would be negative 1/2 and then square root 3 over 2. Wasn't a very good 3.
Jesus Christ. What
Yes, you will have spaces to actually put them.
we might do it real
Guys, shh. 150 degrees is a reflection of what angle?
It's going to be
30.
The 30.
as 120.
So what about the signs?
It's going to be negative.
Negative square root 3 over 2. positive 1/2. Okay, 210 is going to be the same as which one? 30 or 60? 30. Both negatives. Square root 3 over 2. Guys, this talking has to stop. All right, 240 degrees. Is that going to be the same as 30 or 60? 60. Both negative. So it'll be negative 1/2 negative square root 3 over 2. All right, 300 degrees would be the same as 60.
Except for the second one is going to be negative.
The y is going to be negative. So it'll be 1/2 negative square root 3 over 2. And then 330 is going to be the same as what?
30.
30. Except the y is negative.
Y is negative.
Square root 3 over 2, 1/2. Now, if you forgot one of those and you couldn't tell it was a reflection, okay, for example, the 240 degrees, you could say, okay, to get to 240 degrees, I've got to go a short horizontal distance and then down a long vertical distance. So the short goes first and the long goes second.